By the end of this lesson, you should be able to identify variables in a given situation, identify a question suitable for scientific investigation, form a hypothesis, design and carry out a simple experiment to test the hypothesis, record and present data in a suitable form, interpret data to draw a conclusion, write a report of the investigation. Two babies with different weights are put in two identical spring cradles. What causes the spring to stretch? Yes, the weight of the baby caused the spring to stretch. What is the difference between spring cradle A and spring cradle B? Spring cradle A stretches less than spring cradle B. What is the difference between the two babies? Baby A is lighter than baby B. What can you infer from the observations? The extension of influenced by the weight hung on it. What are the variables involved? The variables are the weight or force acting on the spring, the extension of the spring, the elasticity of the spring, the initial length of the spring. What do we want to find out? We want to find out whether the weight acting on a spring affects the extension of the spring. Design an experiment to investigate this. To determine the relationship between the extension of a spring and the force acting on it, we can conduct an experiment using a spring and slotted weights. The aim of this experiment is to determine how force acting on a spring affects its extension. What is your hypothesis? The bigger the force acting on the spring, the greater its extension. To test this, you need to identify the variables involved. To help you do this, you can ask yourself the following questions. What do you change? Force acting on the spring. Weight hung on the spring. What do you measure? Extension of the spring. What do you keep the same? The elasticity of the spring, the initial length of the spring. If you were given a spring, slotted weights, a needle and a meter ruler, how would you set it up? How will you carry out your experiment? Procedure. The apparatus is set up as shown above. The needle lies horizontally to the upright meter rule. The initial position of the indicator LO is marked before a weight is attached to the spring. The slotted weight of 50 grams is hooked to the bottom of the spring. The new position of the needle L is recorded. The experiment is repeated with 100 grams, 150 grams, 200 grams and 250 grams. The data is recorded in a table. A graph of extension against force is plotted. Let's now carry out the experiment. Note the starting position of the pin, LO. Start the experiment by dragging the weight holder of 50 grams to the bottom of the spring. Record the new position of the pin, L. Calculate the spring extension and key in the value. Repeat the experiment by adding more weights to the spring. Now plot the graph. What can you say about the relationship between the force acting on the spring and the extension of the spring? The graph obtained is a straight line. This shows that extension increases in direct proportion to the force acting on the spring. From the investigation, write a report. The report may look like this.